find it out.
It would be wise if you had. But let's look at, so this is worksheet 1, number 4. Capital F of x equals the integral from -1 to x squared. Already I'm thinking chain rule because that's x squared up there, not just x. Determine the x coordinates of any points of inflection on f of x. Justify your answer. Well, justify your answer. I like to justify first because it lets me know what I'm looking for. Let's just start with f. F has point of inflection when f double prime changes signs. So I've justified my answer already. I mean, not completely. I need to find f double prime and do some more work, but that's helps me know what I'm looking for. When f double prime changes signs. So I need to take a derivative to get f prime. So f prime of x, or capital F prime of x, derivative of an integral. This is what we like. They cancel each other out with the warning that we need to plug in the top value and then also include the chain rule. So 3 times x squared minus x squared squared, and then all of that times 2x. Chain rule. So that's kind of a mess. I know I'm going to need a second derivative. I don't really want to, I mean, I could view a second derivative from where it sits right now, but that would require product rule. So I think I want to clean this up first. That'll make my second derivative a lot easier. Let's see if I can do this all at once here. 3x squared times 2x would be 6x cubed minus x to the 4th times 2x would be minus 2x to the 5th. So that's still the first derivative. It's just a lot cleaner looking than this original thing, so that when I go to find the second derivative, it should be a lot easier. 18x squared minus 10x to the 4th. Okay, so I need to set that equal to 0. Maybe put them on the number line and check the plus minus to see where, if I can figure out where things change. So I'm going to factor out a 2x squared. That would get me 9 minus 5x squared. So that one's going to lead to x equals 0. If I set this other one equal to 0, I get plus or minus the square root of 9/5. That's no fun. But I think this is going to be okay number line wise. 0's in the middle. Negative root 9/5 and positive root 9/5. Not my favorite numbers to deal with. But I think 1 is less than the square root of 9/5, right? 9/5 is bigger than 1. So for a test value, I can test 1 and negative 1. And then 9/5 is not quite 2. So I think I can test 2 and negative 2. And if I'm really paying attention, this x equals 0 is a double root. So I'm not expecting the I'm not expecting a sign change across 0. Right, a double root is a bounce, sometimes we call it that. So this is either going to be plus plus or minus minus across the 0. All right, let's plug in -2. Let's use a calculator to plug in -2 rather than mess this up. 18 times 2 squared minus 10 times 2 to the 4th. And maybe you recognize that -2 and +2 are going to give you the same answer because squaring and fourthing. So they're both negative. 2 and -2 are both negative. F double prime is negative. And I bet if I plug in 1, well, that's an easy one. 18 minus 10 is positive. Both of those are the signs of F double prime. So the point of inflection is the x-coordinate anyway, are the plus or minus 9/5, square root of 9/5. Because that's where the sign changes for the second derivative. That was kind of them to only ask for the x-coordinates, because if it had asked for the y-coordinates, I'd have to come back here and plug in the x, and then I would have had to take an antiderivative, and I mean, I could have done it, it just would have been a lot more work to do.
Well, are you going to do that to us?
Not at this level, no.
So like on the test, you're going to do that to us?
Not with the number that this is this bad.
No.
So I might ask you to do it, but it would be one that wasn't this square root and yeah.
So you just plug it in.
So yeah, if I wanted f of square root of 9/5, I mean, that would be the integral from -1 to 9/5 after I square it, of 3t minus t squared dt. And so that's a doable problem. You antiderivative this and this, and then you plug in 9/5, and it's going to be ugly, but it's not impossible. And with a safe stop, I would definitely leave it safe stop so you don't mess up, the cube of 9/5. It would just be ugly. It would not be difficult even. It would just be tedious. And we try to give you difficult problems, not tedious problems. All right, so that was number 4. What else? So let's look at number 6 off of worksheet 1, and then we'll move to worksheet 2. And again, there'll be a hodgepodge of videos posted where almost all of them are worked now. The graph of the function f, consisting of 3 line segments, is given below. G of x is the integral from 1 to x of f of t dt. Compute g of 4 and g of -2. G of 4 means integral from 1 to 4, f of t dt. So the area, again, this either means area or antiderivative. Well, it means both, but depending on what you've got in the problem, that tells you how to, or which way of thinking about the problem. For this, since this is nice straight lines, we're thinking geometry. We want area under the curve. And we don't have a formula or an equation to antiderivative anyway. So from 1 to 4, okay. Well, from 2 to 4, I can get that pretty easily. 1/2 and -1/2, those would cancel out. But I need to get this area from 1 to 2. So that's a trapezoid. Width is 1. The average height, or the 2 heights, are 4 and 1. So that area would be 5/2. if you ever really get stuck on the area of a trapezoid, you could just make it a square and a triangle and add them together. But whatever, the whole area is 5 halves. So the area from 1 to 4 is 5 halves plus a half minus a half would be 5 halves. So that's g of 4. G of negative 2, integral from 1 to negative 2. Okay, so what do we notice about that? It's negative or it's backwards. I need to flip it. Kind of all those mean the same thing. So I'm going to show the work of flipping it. If you're comfortable enough kind of reading backwards, you can. So now I switch things around so I can read my graph from left to right, from negative 2 to 1. Let's see, that's 3 wide, 4 high. 3 times 4 is 12. Divided by 2 is 6. So that area is 6, but because we were backwards, the integral is negative 6. And again, some of you are going to get to the point where you don't show that middle step. You find the area is 6. You know you're going backwards, so it's negative 6. And that's okay. Part B, the instantaneous rate of change of g. That's fancy talk for what? Derivative. So g prime of x at 1. Oh, so I need g prime at 1. Well, I've got room up here. So if I want g prime, I need to take the derivative of both sides. The derivative of an integral cancels each other out. And plug in x. Chain rule is times 1. Most of you are not going to write that, but I'm writing it to emphasize and remind you to not forget the chain rule. So this means g prime at 1 is really just f of 1. So I'm just going to go to the graph, and what's f of 1? 4. It's just the graph at 1 is equal to 4. Yeah, I'm going to go ahead and label my graph while I'm thinking about it. It's the graph of f of x, but that's also the graph of g prime. So not necessary to do that, but maybe helpful. Find the absolute minimum. Check in points, check in points, check in points. Although we already found g of 4 and g of negative 2, so that's nice. Absolute minimum value of g on the closed interval. Justify your answer. Okay, well, the relative minimum of g would be where g prime changes from negative to positive. But g prime is the same as f. And I've already said that g prime is the same as f, so I don't need to restate this as f changes negative to positive. You can, because that's what your brain is thinking, and if you want to write it down, you can. But, or some people will just kind of write it right above, like, hey, I know that g prime and f are the same thing. So f changes negative to positive nowhere. Okay, so there are no relative minimums. So all I need to worry about is the endpoints. Negative 2 and 4. And we already found both of those. Okay, now let's make sure we answer the right question. The absolute minimum value of g. So if this is a multiple choice question, Which one is the absolute minimum of G? You got it narrowed down. It's definitely not that. That's the maximum stuff. Well, the minimum value is -6 because that's the y value. This is the x where it occurs, but that's not what it asks for. Part D, the second derivative of G is not defined at x equals 1 and x equals 2. Right, because those are sharp points. And the second derivative of G, if I start right here, the second derivative of G is equal to the first derivative of f. So there are sharp points at 1 and 2. So yeah, we know this. The second derivative of G is not defined. How many of these values are x-coordinates of points of inflection of G? Justify your answer. So POI of G happens where G double prime changes signs. And G double prime is the same thing as F prime is the same thing as the slope of F. I don't have to write all that down. Well, I have to write it down somewhere, I guess, but I already have it written down over here. So I'm looking for where the slope of F changes. So that happens at x equals 1, but not at x equals 2. It's negative, it changes, but it doesn't change from negative to positive. It just stays negative. So just x equals 1. Questions on that one? Again, the big thing is getting started. Take the derivative of both sides and realize, aha, the derivative of one of the functions is just equal to the other one. And then you can take more derivatives as needed. And then you just got to remember all the old rules about increasing, decreasing, and concavity, and points of inflection, and all that stuff.